This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Did you know that the fastest human-made object in existence is NASA's Parker Solar Probe? And it's gearing up to break its own record by the end of this year. On March 30th, 2024, it matched its own closest approach to the Sun of 7.26 million kilometers from the solar surface. And on December the 24th, 2024, it will smash all previous records both in proximity and velocity. On December 24th, aided by a gravity assist from Venus on November the 6th, the probe will come even closer to the Sun, to a mere 6.12 million kilometers away. This close encounter is not just about breaking records, it's also to increase the probe's speed to an astonishing 692,000 kilometers per hour, which would get it from New York to London in about 30 seconds. Wow! How did the probe come about? Here's a little history from NASA Space News.
Parker Solar Probe is not just a spacecraft, it's a dream come true. A dream that started more than 60 years ago, when a physicist named Eugene Parker predicted the existence of the solar wind. He was the first to realize that the Sun's corona was so hot that it could escape the Sun's gravity and create a supersonic flow of plasma that filled the space around the Sun. Parker's theory was revolutionary, but it was also controversial. Many scientists doubted him and challenged him, but he was right. And NASA decided to honor him by naming their most ambitious solar mission after him, Parker Solar Probe. Parker Solar Probe was launched in 2018 with a bold goal: to touch the Sun. To do that, it had to fly closer to the Sun than any spacecraft before, and it had to survive the extreme heat and radiation of the Sun's atmosphere. But how did it do that? Well, it had some clever tricks up its sleeve. First, it had a powerful rocket that boosted it to incredible speeds. At its fastest, it can zoom around the Sun at about 430,000 miles per hour. That's fast enough to get from Philadelphia to Washington, D.C. in 1 second. Second, it had a thick shield made of carbon composite that protected it from the Sun's heat. The shield can withstand temperatures reaching nearly 2,500 degrees Fahrenheit, 1,377 Celsius. That's hotter than lava. Third, it had a smart cooling system that kept its instruments at a comfortable temperature. The system used water to circulate heat around the spacecraft and radiate it away. And fourth, it had an autonomous software that controlled its orientation and attitude. The software made sure that the shield always faced the Sun and that none of the other parts of the spacecraft were exposed to direct sunlight. Thanks to these tricks, Parker Solar Probe could fly closer and closer to the Sun, breaking records and making history along the way.
Recently, the probe made a new discovery about solar winds and how they're created. Here's more on that.
In a new paper published in the journal Nature this week, reveals a groundbreaking discovery made by Parker Solar Probe. It shows that the fast solar wind comes from regions of open magnetic field on the Sun called coronal holes. These are areas where magnetic field lines stick out of the surface without looping back inward, creating open channels that allow plasma to escape. Parker Solar Probe also found that these coronal holes are like shower heads, with jets of plasma emerging from bright spots where magnetic field lines funnel into and out of the surface. These funnels are huge, about 18,000 miles across, and have very strong magnetic fields. But how do these jets produce the solar wind? Well, Parker Solar Probe has an answer for that too. It detected bursts of high-energy particles that match the pattern of these funnels, suggesting that they are caused by a process called interchange reconnection. Interchange reconnection is when oppositely directed magnetic fields pass one another in these funnels and break and reconnect, slinging particles out of the Sun. This process releases energy and creates pressure and flow bursts that drive the solar wind. The paper shows data from Parker Solar Probe's instruments, such as plasma velocity, ion energy, and magnetic field direction. It also compares the data with computer simulations of interchange reconnection and calculates the energy release rate of this process. This discovery is crucial as it helps us know how and why the solar wind is generated and accelerated. It also shows that Parker Solar Probe has entered the sun's upper atmosphere for the first time, touching the very essence of our star.
So how does this solar wind discovery help us here on Earth? The data gathered by the Parker Solar Probe is invaluable for solar scientists who study the solar atmosphere, its magnetic fields, and the solar wind. It helps them to understand the sun's behavior in order to predict space weather, which can have profound effects on Earth's technology and power grids. Since we live in the sun's atmosphere, what happens on the sun affects us here on Earth. The solar wind carries not only particles, but also magnetic fields that interact with Earth's magnetic field. This interaction can create beautiful auroras, but it can also cause geomagnetic storms that can damage satellites, disrupt power grids, and harm astronauts. Also, the solar wind is not always steady and smooth. When it changes speed or density or even temperature, there are explosions on the sun called solar flares or coronal mass ejections that can send huge bursts of solar wind towards the Earth. These bursts can arrive in a matter of hours or days and cause severe space weather effects. Understanding how and where the solar wind originates will help us predict these events and prepare for them so we can help us protect our technology and infrastructure from potential damage. Studying the sun also helps us learn about other stars in the universe. Our sun is our closest star and our best laboratory to test our theories and models of stellar physics. The Parker Solar Probe is opening new windows into the star and its mysteries. And it still has more orbits to complete, each one bringing it closer and closer to its final destination of about 3.8 million miles or 6 million kilometers from the sun's surface by 2025. That's when the Parker Solar Probe will truly touch the sun like never before. Thank you for joining me, and thank you for listening from your home or where you work. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.